All right, chapter 10.6, we're talking about secants, tangents, and angle measures, okay? So tangents, okay, we talked about that as 10.5. Tangents intersect at one point, not points. Secants, you guys want to guess, is going to be a line that intersects the circle, and not 1 point, but 2 points, okay? So you guys could think it's like a chord, but it's gonna be different from a chord, okay? And then you guys can probably see why here. So if you guys are following along, feel free to draw a circle. If not, just pay close attention. Okay, so I'm gonna draw a circle. Don't label it yet. Okay, so we have a circle here. And we're gonna draw 2 secant lines, okay? Secant, okay? Say that to yourself real quick. Secant, okay? Secant line. So let's draw 2 secant lines. So boom, I'm gonna draw this one. Bam, 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 okay? Can we see why this is different from a chord? Okay, a chord is a segment that hits the circle twice, okay? Where secant is a full line, okay? It goes completely through. Let's just label this. You guys are labeling. Let's go A and then go clockwise. B, C, and D, okay? So these will be the type of diagrams you'll be working with. And so right now, my goal is to see what is angle, let's call this here angle 1, okay? I should make it look like this. Okay, my goal is to see what relationship can I use with this diagram to let me know what is the measurement of angle 1, okay? Now here's a little hint. Check this out, look what I'm doing. I'm gonna connect DC. Boom, okay? I'm gonna connect DC, now we have a triangle here. Boom. So angle 1 in relationships to that triangle, right? Let's look here, angle 1. You guys remember this throwback? Let me give you an easy example here. What would angle 1 be in regards to angles 2 and 3? You guys remember?
Exterior angle.
Boom, the exterior angle is beautiful. Okay, so angle 1 will equal angle 2 plus angle 3, okay? Just from a throwback, right? These are our exterior angles, okay? But now let's take a look at this. Okay, so I'm gonna use this, okay? This is our template right here. This is our template. So look at angle BDC. BDC, this angle. This angle is gonna be called, let's see here, angle D, right? Let's call angle D. Angle D is what we call a inscribed angle. Okay, right? It's in the edge of the circle, inscribed angle. Okay, same thing with angle C here. Okay. So now I'll kind of jump ahead a bit. All right, so angle 1 is equal to what? 2 angles. Angle 1 from this right here, right? Angle 1 is going to be equal to angle, I'll just make it easy for us. I'll just say angle D plus angle C, okay? Cool. Thumbs up if we're in agreement with that. Angle 1 in this diagram is equal to angle D plus angle C. Okay, let me know we're good with that. Okay. So now what we're going to do next here is seeing that these are inscribed angles, okay? So inscribed angles, the relationship deals with the arcs. Okay, so right here, angle BDC uses this arc, okay, CB, boom. And then angle ACD uses this arc, boom, do you see that? Okay, for DCA, okay? Hopefully we can see that. So a little substitution here. Okay, look in this next question. What arcs do the two angles intercept? Okay, so again, in purple, that is arc CB. Okay, arc CB, and that is intercepted by angle D. Okay, this angle here. I hope you guys see that visual. And so the relationship of the angles and the arcs. Okay, so angle D is equal to 1/2 of arc CB. Boom. And then angle C is equal to 1/2 of the arc DA. Boom. I'll make that blue. Okay, take a look at that. Okay, and our goal is we're trying to see what angle 1 is. Okay, our goal is to solve for angle 1. Okay, like what is angle 1 in regards to the arcs? So now what we can do here is we substitute. Okay, we're going to substitute these angles and switch it out with the arcs. So now I'm going to have angle 1 is equal to, if I write it smaller, angle 1 is equal to 1/2 CB, which is angle D, plus 1/2 of arc DA, right? These are arcs. And to make this equation look a bit nicer, I can factor out the 1/2. So 1/2. Oh, and technically they're the measurements of the arc, so I'll put the M there. And boom. Okay, look at this. Okay, look at this formula for what angle 1 is, and look at the actual diagram. Okay. So angle 1 is equal to 1/2 of the two arcs that it hits. Okay. If you look at angle 1, right? Angle 1 is formed by this line, boom, and this line, right? And then you kind of just ask yourself, what do those two lines intercept, right? It intercepts those two arcs, the purple arc, CB, and DA. Okay. And then boom, that's your formula. Okay, give me a thumbs up if you're cool with that. Okay, and again, this whole process was just to get us to our new formula for the day. Okay, so the only thing you need to fully understand is, or memorize, is this formula. Okay, but understand that this formula came from, again, the most powerful shape, a triangle. Okay, all right, all of a sudden we have this angle here, and we are able to form this triangle by connecting DC. So making that triangle, and then use your two inscribed angles to connect it with the two arcs here, right? Those two inscribed angles equal 1/2 of those arcs. And it ends up being these arcs are being intercepted by the two secant lines that make angle 1. Okay? All right,